Okay. We're just going to apply a lot of the same steps we've been doing already. It's not going to be too ugly. We just got to be a little more conscious to make sure that we've done everything we can do to factor it out. Now, part of it is actually going to be using steps that we've already been covering. The first example is about factoring out a binomial. We've already been doing this because we've used a slightly different method than the book has been using. Right, what factors out of those two pieces?
X plus 4 and...
No. X plus 4 is what factors out. That's it. Okay. What's left when I factor those out? 2x minus 3. Okay. So make sure we're answering the right question here. Okay. X plus 4 is what they have in common, and then we're left with 2x minus 3.
So all you do is just identify it?
Indentifying, yes. Yep. Starting a new paragraph. Yep. Or indentifying. All right. Now, where we have to be really careful is where some of our terms look the same but are really different. Like this one here. We got 3 squared times y minus 2 plus 5 times 2 minus y. Are y minus 2 and 2 minus y the same thing? They're not. But they are very close. Well, sort of.
So be y minus.
They're actually exact opposites.
So they become
Y minus 2 and 2 minus y are exact opposites. They would become 0 if I was adding them, but I'm not. I'm factoring them.
It would still be the same.
No. Think about this. If they're exact opposites, that means that 2 minus y is the same as negative 1 times y minus 2. That's what they mean to be exact opposites, right? So what I can do is I can take that negative 1 and apply it to the 5 instead. Now I've got 3y squared times y minus 2 minus 5 times y minus 2. Now what do they have in common? Y minus 2. And what's left over when I take that out?
3y squared minus 5.
There
Plus
you
5.
go.
Wait, no.
Minus 5. Remember, we changed the sign with that negative 1. Good? So far, so good? All right, let's look at the next one. This is called factoring by grouping, which we've actually been doing already. We're just going to make it higher power now. And since we're in a Christian school, you ought to be able to appreciate a higher power. All right. What do the first two terms have in common? Isaiah?
They're, like those two?
Yeah, the first two.
They're all, they can factor.
Yes, they can factor.
A perfect square.
X cubed is not a perfect square. What do they have in common? What can I factor out of both of them? X
and
squared, because they both have at least 2 x's. Okay. What am I left with when I factor out an x squared? When I take x squared out of x cubed, I'm left with
x plus 3.
X, and when I take it out of 3x squared, I'm left with 3. What can I factor out of the 5x and the 15? 5, and I'm left with x plus 3, and I should know how to factor this. What does it become?
It will become
x plus 3.
And x squared plus 5. Awesome.
Oh, that's really easy.
That's it. Okay, we've been doing a process just like it for factoring our regular trinomials. They just kind of separate them into 2 steps. This, I think, works a little easier. Now let's do one that's all letters. We call this a post office problem. Nobody's ever called it that. I just made it up, and now it's going to go viral. For the 5 people that watch this video. Yes, and 4 of them are in here.
Subscribed.
All right. What factors out of the first 2?
y.
No, because I want to know. What factors out of the first 2?
Y.
Why?
No, in these 2. We got to know, and otherwise we can't factor it completely. All right, y factors out what's left.
Y plus 1.
Did you just call me Porky?
Porky.
This is why we don't do a video with my face in it, so nobody notices I'm large. Thank you, Spence. All right, what factors out of the second two?
X.
X. Now, unfortunately, like most issues in real life, you can't just get rid of the X. You have to keep it. You know, it's always hanging around.
Y plus
But what are we left with when we factor the X out?
Y plus 1.
Y plus 1. All right, what do we have in common now with our two pieces?
Y plus 1.
Y plus 1, and what's left when we factor out Y plus 1?
Y plus X.
Y plus X. Awesome!
It doesn't matter which way you write it.
No, it doesn't. You can do Y plus X times Y plus 1. Okay? You guys are just trying to fluff out the video now. Like, these are fun! We love them!
No, I just think
This video's gonna go famous on Yahoo now. These freaks actually love factoring. What weirdos.
Good thing they don't see any of our faces.
we have ever had. It was too much, you guys.
Let's do another one.
I don't understand it.
Here we've got to do some rearranging. If you notice, the way this is written right now, the first two terms don't have anything in common.
Oh,
Right? We need to rearrange.
so you would plus 3x squared?
You're not going to plus 3x squared because there's no equal sign. I'm not moving it to the other side.
You're going to
I'm just moving it around. No, I can't add anything to both sides. I can't move things to both sides because there's only one side. All I'm going to do is change the order. Okay, so we go from highest power to lowest power. Now the highest power is already first. What goes next? Yes.
Negative 3x.
Negative 3x squared. Make sure the sign goes with it. Okay.
plus 2x
Plus 2x is the next term,
minus 6.
and then minus 6. Now everything's in order. And notice, again, the signs go with the numbers. It was a negative 6 there. It's got to be a negative 6 over there. There's a negative 3x here, or 3x squared there. It's got to be a negative 3x squared there. Now what do the first two terms have in common?
X minus 3.
X squared.
Oh, wait.
X squared.
So
And we're left with x minus 3. What do the next two terms have in common?
2.
2. And we're left with x minus 3. All right. Come on, catch up there, screen. All right. Now, what do the two pieces have in common?
X minus 3.
And what are we left with?
X squared plus 2.
X squared plus 2. Fantastic. That's all we got to do, except for to check that it's factored completely, and we'll get into this a little more tomorrow. You got to make sure that when you're done factoring that there's no pieces that can be factored further. Okay? So you got to make sure that when you get this done, these pieces can't be factored any further. You can't factor x minus 3 out any further. You can't factor out x plus 2 or x squared plus 2 any further. We'll get into that a little bit more tomorrow. All right.